railway station just after 9 p.m. on Sunday the 28th of April to reports of a stabbing. The teenager was taken to hospital, but his injuries were not thought to be life-changing or threatening. Humza Yousaf has resigned as Scotland's First Minister after cutting ties with his government's power-sharing partners. The SNP leader, who only took the role last year March, said he will stay on as First Minister until the Scottish National Party chooses his replacement. He said he underestimated the level of hurt after ending a power-sharing deal with the Scottish Greens last week and told reporters he wasn't willing to trade his principles just to hold on to power, and became visibly emotional as he paid tribute to his wife and children. New laws came into effect from April the 29th regarding regulations enforcing consumer protections against hacking and cyber attacks. These laws state that internet-connected smart devices meet minimum security standards by law. Manufacturers will be legally required to protect consumers from hackers and cybercriminals from accessing devices with internet or network connectivity, from smartphones to games consoles and connected fridges, as the UK becomes the first country in the world to introduce these laws. And now for African news. A dam collapsed in western Kenya on Monday the 29th of April, killing at least 40 people after a wall of water swept through houses and cut off a major road, police had said. The old Kijab Dam, located in the Mai Mahiua area of the Great Rift Valley region that is prone to flash floods, collapsed and water spilled downstream, carrying with it mud, rocks and uprooted trees. And that's the latest from Jambo Newsroom. I'm Andrew Baini.
Need security? Call Alpha One Plus Limited, a strategic security resourcing platform that connects you with licensed security personnel. We cater for our clients' security needs, from manned guarding, door supervision, event security, all the way up to close personal protection. Alpha One Plus Limited, your one-stop security solution. Call now at 44-074 2526 7909 or send us an email on info@alphaoneplus.com.
Established in 2006 as one of Glasgow's original mobile massage therapists, we deliver high-quality treatments with the ambition to forge permanent relations with clientele. We specialise in on-site massage, a type of treatment that has been specifically designed to complement the convenience and availability of massage at work. It is performed with the use of a specialist mobile chair, without the use of oils or the need to remove clothing. At Massage & Glow, we believe that massage should be a part of your everyday lifestyle. Regular massage not only relieves stress and tension, but also stimulates blood circulation, can help with pain management, and promotes good mental health. A must for your busy schedule. Various holistic therapies available. Contact us now on 07530 905 152 for your mobile massage therapist.
This is the Science Show with Dr. Dada. It's just so nice, you cannot do without. This is the Science Show with Dr. Dada. It's just so nice, you cannot do without.
Hello and welcome to everyone, visionaries, dreamers, to yet another groundbreaking episode of the Science Show with Dr. Dada, here on Jambo Radio Scotland, broadcasting from the city of Glasgow. As usual, I'm here today, your host, Dr. Adetumishi Dada, coming to you live from Glasgow. Now, I'd like to paint a scenario for you. Imagine a world where your windows optimize sunlight in order to save power for your home, or where your clothes monitor your health. Can you imagine that? Just by putting on clothes, it can monitor all your vitals. And what about a world where your car paint warns you of any issues, any mechanical issues, before they happen? Now that sounds like something out of science fiction, doesn't it? But we'd like to ask you to brace yourselves, because that future is actually knocking on your doorsteps. Today we're going to be diving into a topic that is quite revolutionary, the realm of metasurfaces. Now, metasurfaces are pretty much miraculous materials. these materials are designed to manipulate electromagnetic waves in ways that defy traditional physics. And we're going to delve into all of that today. Now, from the sci-fi pages to the real world, well, metasurfaces are transforming everything from telecommunications to healthcare to sensing in other aspects as well. And today we have two of the brightest minds from the James Watt School of Engineering at the University of Glasgow right here to help us unwrap the science behind these magical devices, if you like. So we'd like to ask you to stay tuned and ignite your curiosity, prepare to have your mind blown and to be amazed as we ask and answer the burning question for the week, which is, how are metasurfaces transforming our world? Well, on the show today, we'll have the usual format. So we'll start with our science news highlights, and then we're going to delve into an interview with our guests. We'll get to know them, but more importantly, we'll get to know the amazing work that they're doing. And that will lead us into our discussion on metasurfaces. So we'll get to know what metasurfaces are and how they are transforming our world. And remember, you can join in the conversation. You can call in and join the discussion. The number to call is 0141 530 2787. That's 0141 530 2787. As usual, today's show will be packed with fun as well. We'll have a couple of jokes that are based on the topic for discussion today, so you won't want to miss that. So if you hang on and stay tuned in to us until the end of the show, you'll get to enjoy that. Perhaps you could contribute a joke or two as well. And today we'll see if our guests are up for it. Maybe we'll have a remix, we'll have a rap about metasurfaces. That should be fun. We'll see if we manage to do that. But you can be sure today's show is packed with fun and there's a lot to be learned from our guests today. So we're looking forward to that. So we'll just have a quick introduction of our guests. So with us in the studio today, we have the pleasure of having Dr. Abdul Jabbar and Dr. Masood Rahman. So it's a real pleasure to have you with us, Dr. Rahman and Dr. Jabbar.
Thank you.
Yes.
It's a pleasure to be on the show.
Yes, thank you very much for being here. We're going to, of course, get to know you in the course of the show. We'll have an interview and get to know what the work that you do as well. But just as an introduction, so Dr. Masood Rahman is a distinguished scholar at the University of Glasgow, and that's in the James Watt School of Engineering. And there he serves as an associate professor or senior lecturer. Now, he's a fervent researcher and his academic journey spans across the globe. We'll get to hear about that more later, of course. But he specializes in the body-centric wireless networks, in remote healthcare technology, and millimeter wave and nano communications for body-centric networks. This is really sounding very, science fiction-y, but I'm sure you'll agree. We'll learn more about that later. His work also includes developments in compact antenna design and the dynamic interaction of electromagnetic waves with the human body. That's something that's absolutely interesting. And of course, fittingly, his accolades include a fellowship at the Higher Education Academy and leadership roles within several IEEE communities. Now, Dr. Rahman's expertise is pivotal in pushing the frontiers of wireless and sensor technology to new heights. I'm sure you'll agree. We also have here Dr. Abdul Jabbar, a recent PhD graduate from the University of Glasgow, and he has rapidly made his mark in the field of engineering and research with his pioneering work on dynamic metasurface antennas at 60 gigahertz millimeter wave band. That's a work that's co-authored with Dr. Masood Rahman, who happens to be his supervisor, his PhD supervisor. Now, we're going to hear a lot more about this work as we progress with the show today. Great. So that takes us nicely into our science news highlights. As usual, we have about 3 highlights to think about this week. There's one of them that really caught my eye in the media recently, and I thought it would be nice to talk about that a little bit. And that is a really viral piece about an orangutan who uses medicinal plant to heal its facial wound. That's really, really mind-boggling to know just how smart these animals are, to have that level of cognitive ability to take, a herb basically and actually apply it, treat itself, is just mind-boggling. Now, this is unprecedented, of course. It's something that's never seen before. This Sumatran orangutan named Rakus was, seen using the medicinal properties of a plant, of a medicinal plant, to treat a severe wound on his face. And for those of us watching, or if you've seen the picture already online, you'll see what we mean. The wound looks really hideous, really bad, actually. It's a really bad gash to the face, but it shows the results here say that the orangutan was able to heal its face within 5 days. The wound had closed up and showed no signs of infection, and that's quite remarkable. So this behavior basically underscores the cognitive ability of these animals. When you think of orangutans, it's something that doesn't cross your mind that they would have the ability to not only feed themselves and do all those usual things, but know to treat a wound, and do so successfully. Not only treat the wound, but know the right plant, know how to mix the concoction and apply it to the wound. That's really interesting results, and draws fascinating parallels between human and animal use of such natural remedies. And some researchers, including cognitive biologist Isabel Laumer and veteran zoologist Michael Hoffman, expressed excitement and hope in these findings that these will deepen public appreciation for animals like orangutans and emphasize the urgent need to protect these critically endangered creatures, underscoring their profound connection to humans. Interesting. Good. So the other headline that caught my eye was this one about belugas. So beluga whales, their expressive communication through their forehead fat. Now these whales, we know they have a blob of fat on their forehead, and in this groundbreaking study at Connecticut's Mystic Aquarium, researchers have found that beluga whales can shape that forehead fat into different shapes, and this forehead fat also is known as the melon, by the way. Now Justin Richard from the University of Rhode Island observed these cetaceans contouring their melon into various forms, such as caps, flattened shapes, and top hats. And these various shapes may serve as sophisticated communication system among these animals. So it's a little bit similar to what humans do. When you're communicating, the expressions on your face, you have control over the muscles, right? You can smile, you can, make your face a little bit less friendly, perhaps. I guess with these animals, they have control of some muscles that can shape the fat blob on their heads, and that is part of a way that they communicate. Now, this study was published in the journal Animal Cognition, and this study followed 4 of these belugas for a year, and it documented nearly 2 distinct melon shapes per minute during social interactions. Now, this behavior, visible to other belugas, suggests the shapes could be intentional communicative gestures, and these can be indicators of emotional states, with some linked to social behaviors like courtship. So that's quite interesting, isn't it? You can read more about that online. It's actually being covered by a lot of news outlets online. Now, to the final highlight that we're going to cover today, and it says pioneering antenna development powers potential for 6G networks. Yes, That's the one. Now, researchers at the University of Glasgow have unveiled a groundbreaking advancement in wireless communications that could dramatically shape the future of 6G technology. Well, I thought we were just getting used to 5G, but anyway, we'll learn more about what 6G is later on. Now, the new prototype, a digitally coded dynamic metasurface antenna, or DMA, represents a significant leap in the world of antenna technology, and it operates at a high frequency 60 gigahertz millimeter wave band. Now, this research was published in the IEEE Open Journal of Antennas and Propagation, and it combines the cutting-edge metamaterials with sophisticated signal processing managed via a high-speed field programmable gate array, or FPGA. Now, we're going to learn a lot more about this through our discussion with our guests, because we happen to have the lead scientists on this work here with us in the studio today. So that's something that we'd love to explore further today. Now, this breakthrough could pave the way not only for enhancing current technology, but also defining future applications in communication, sensing, and imaging, and that makes it a cornerstone for the nascent 6G infrastructure. And that wraps up our news highlights for today. But we're going to learn more about this last item, of course. And that takes us nicely into the first part of our interview, where we'll get to know a little bit more the scientists behind this work. So, once again, we are so happy to have you with us in the studio today. Perhaps we could start with Dr. Masood Rahman. Now, with your expertise, extensive work in antenna design and wireless communication, could you share the moment that sparked your interest in science, in this field as well?
Well, basically I started my PhD back in 2006, and the interest in antennas and electromagnetics, the science behind this field, science behind the waves, extraction of information from the waves, started during masters when I did a project on antenna design. So I found this field very interesting, as the antenna can be considered as eyes and ears of any communication system.
Yes.
So if you have got a state-of-the-art system behind, but very poor kind of antenna, then relaying of information efficiently is not possible. So
Yes.
as we are doing this interview, and we are talking about radio, right? So any excellent radio system is blind if we do not have a good antenna at the front end. So that was the starting point of my interest in this field. So I designed an ultra-wideband antenna during my master's, and then my supervisor encouraged me to start my PhD in the same field. So I did the same research, slightly on different application areas like Bluetooth, GPS, and then on-body communication. That is one of the major areas of my research.
Good.
So, currently we are trying to have most of the communication systems as either wearable or implantable or portable.
Yes.
Right? We are having this smartwatch or mobile phones, so laptops. We have got a number of implantable sensors. So we try to carry the communication systems with us everywhere all the time. This is only possible if we have got a good antenna,
Good antennas.
in
Yes.
these devices.
Yes. Very good.
So that started my journey in this field, and now I'm at a point where we are having a number of applications,
Yeah.
number of solutions
Good.
in this system.
Excellent. And we're going to learn a lot more about these applications as well. Now, to you, Dr. Jabbar, could you share something similar with us as well? What inspired you to explore this specific area of communications?
Yeah, first of all, thank you so much for the invitation. So my journey is not too much far. It's a quite recent journey. I'm an early career stage researcher. So my journey started from the electrical engineering subject, from the signal processing and telecommunication. And the wireless communication actually always fascinated me, the way it emerged in the last decade, especially from the smartphones and the smart applications, state-of-the-art applications which we have in hand or today. So this is something is not very dramatic. Indeed, there is a huge amount of research work and something which has been done, and people are thinking about that. So this was a driving force for me to research about this field and to develop more insights and interest in this field, in fact. And that is the reason I pursued my higher studies, such as master's and then PhD in wireless communication system. And I also tried to develop something novel in my PhD research, especially, and to look where actually the novel and the current state of the art is heading to. For example, the state of the art technologies, which is more application oriented and emerging field of studies. So with the need of the hour, of course, it was aligned to my research areas. And this was one of the most interesting and main reasons that we should explore this field, in fact, in more depth as well as breadth.
Yes, thank you very much. Very well said. Thank you. And with that, we'll get into our first music break. When we're back, we're going to learn more about some of the deeper details of these technologies and the research done by these brilliant scientists. To take us into that, we'll listen to a song by Flavor, and it's Big Baller. We'll be right back.
If you know, you know. But if you don't know, you know.
Now you know. Now you know. If you know, you know. The big ballers in town. Now you know. Now you know. Forget what they know them. Yes. Agba baller. How much is money?
It's nothing.
Ballin'.
Alakwa.
Premium or nothing.
When them or nothing.
Now you know.
Now you know.
Now you know.
Now you know.
Forget what they know them.
Undisputed.
Unopposed. Luxury or nothing. Money is talking. Money is talking. Blessings on blessings. Forget what I know them. Yes. Agba baller. How much is money?
It's nothing.
Ballin'.
Alakwa.
Premium or nothing.
When them or nothing.
Now you know. Now you know.
Now you know.
Better forget what I know them.
Better know.
Wow, that's really nice. Got me moving in my chair there. That was Big Baller by Flavor, also known as Flavor of Africa. And this is the Science Show with Dr. Dada on Jambo Radio Scotland, broadcasting from the vibrant city of Glasgow. And we would like to take this opportunity to shout out to our sponsors, including the IOP and EPSRC, University of Glasgow, for giving us the environment and for funding the nice research that we can do and share. And it's also a nice opportunity to encourage you to join the conversation on our show today. The number to call is 0141 530 2787. 0141 530 2787. Of course, whether you're in the car, whether you're out in the garden, you can listen to our show because we're on DAB. You can listen to us online. You can catch up on updates on our show through our social media handles, Jambo Radio Scotland, and also T Science Show on all platforms. And that way you can know and catch up with previous episodes as well. So now what we're going to do is we're going to get to know our guest even better. And so the question I think will be good to ask now is regarding your research. Of course, your research journey or your journey in STEM has taken you to different institutions, perhaps around the world, especially for you. So how these experiences, how would you say they have influenced your approach to innovation and collaboration in engineering?
Well, I started this journey from Pakistan. I did my bachelor's in Pakistan, and then I moved to the United Kingdom to do my higher studies. I did my master's and PhD in Queen Mary, London. So I would say that my mother institution, University of Engineering and Technology, Lahore, Pakistan, prepared me well by providing all the fundamentals and basically established the base. Then Queen Mary strengthened that knowledge by giving me a flavor of research. This is one of the elements that is slightly missing in our countries. So when I came to do my master's, especially in my final year project, I had the opportunity to work with leading antenna researchers. So Queen Mary has got one of the biggest antenna research group in the UK with all the state-of-the-art facilities. So I worked with a number of people who basically polished my skills and who encouraged me to try out of the box solutions, to think differently about the engineering problems and devise some solutions. Then I came to Glasgow, and Glasgow definitely offers one of the very vibrant research environments, a very excellent research culture, being supported by academics, by the facilities and so on. So this whole journey, I would say I'm blessed that I have been had the opportunity to work with world-class researchers and establish myself as a researcher in the field of antennas and electromagnetics.
Fantastic. Very good. Thanks for sharing that with us. And for you, Dr. Jabbar, could you tell us a little bit more about this whole idea of 6G? Many of us are barely getting used to 5G yet. What is, can you explain how your work on 6G could transform everyday technology, just briefly?
Yeah, so if we see about the initial mobile generations, for example, if our mobile phone supports as well 3G and 4G. So these actually technologies were mostly oriented towards the mobile connectivity only. But with the advent of more and more sophisticated applications, emerging application, for example, remote telepathy, remote robotic controls, remote surgeries and healthcare applications, augmented reality and so on. So it becomes more than the simple connectivity. So that actually gave birth to 5G. And 5G had some specified key performance indicators, for example, how much speed you need, how much bandwidth you need. And with more and more sophisticated applications, such as smart factories and remote health caring and integrated sensing and collaborative communication, 5G was also even not able to cop that. So that is actually the reason of birth of 6G actually. So this is all about the services which human beings expect with the proliferation of wireless technologies and more emerging applications. So this is actually where our research is heading to, that how to cope the requirements of 6G. And one of the main avenues is of 6G is also to reduce the carbon footprint, which was not already taken up in 4G and 5G, along with the mobile technologies. So all of these things, high bandwidth, high speed, and real-time applications which users should experience. This is all about the 6G.
Fantastic. Thank you
all
very
this
much.
Science fiction.
Yes,
You were mentioning right in the beginning.
Exactly. And so, just for the person out there who wonders, what does the G stand for in these G's? What does it stand for?
So G is actually the generation of the technology, the so-called generation. So there are a set of requirements and set of rules and regulations and standards revolving around certain requirements. And after that, of course, research is quite ahead then of the real applications. And then the next generation of the technology or anything evolves actually, and which we call as G, the 6G. And we don't know what will be the 7G or like that.
Yes, good. So the G is generation, isn't it?
Yeah.
And so what kinds of things set the standard for a generation? Like what advances big enough for you to define a new, this is the next generation, perhaps?
Well, your aims, what you want to achieve as a researcher, as a research community.
Yes.
And also all the generations of communication systems are application specific.
Yep.
As Dr. Jabbar was mentioning, that 5G was aiming to have, very large speed, high data rates. Now 6G is aiming to have virtual reality, the augmented reality. So we have got 5 senses, in communication systems, we are able to achieve, or we are able to replicate 3 senses already. So we can see things, we can hear things, we can, talk about things. Now we are trying to get a, realization of whether we can feel things or whether we can touch things. So this touch and feel requires more data rate, more wider bandwidth, more sophisticated systems. So these things, 5G was not able to achieve these things. So now we are heading towards 6G. 6G is building upon 5G, but having more, sort of extension of 5G to achieve more wider data rates, even more speeds, and more sophisticated systems.
Good.
So whenever we aim for better things, or we try to improve on the quality of existing systems, we head towards a new generation of communication systems.
Wonderful. Thank you for breaking it down for us so clearly. Good. So, well, we don't know, as you said, we don't know what 7G is going to look like.
We don't know.
Interesting to see. Good. Fantastic. So what we'll do next is we're going to get into the discussion of our question for the week. And again, that question is, how are metasurfaces transforming our world? So, what role do metasurfaces play in this advancing of these next new generations of communication standards? So, but before we do that, we're going to listen to another nice track. It's by Johnny Drill, and it's My Friend. We'll be right back.
Nobody send you, that's when I care for you, my friend.
my shoulder, make you rest upon me. You know I got you. Now me be your friend indeed. My money don't show now. I don't keep some for you. You know go so far. Cause anything I get now for me and you. Yeah. How are you, my friend? How do you do, my friend? I know sometimes it be like say nobody send you. That's when I did for you, my friend. How are you, my friend? How do you do, my friend? I know sometimes it be like say nobody send you. That's when I did for you, my friend. Oh, Remy, Tata, you always stay in my mind. Padi me gone, gone, gone. I cherish you with my life. Don't worry yourself, oh. Everything go day alright. And if anybody try you, you know it's gonna be on sight. See my shoulder, make you rest upon me. You know I got you. Now me be your friend indeed. I'm money don't show now. I don't keep some for you. You know go so far. Cause anything I get now for me and you, yeah. How are you, my friend? I see you, my brother. How do you do, my friend? I see you, my sister. I know sometimes it be like say nobody send you. That's when I did for you, my friend. So long. How are you, my friend? How do you do, my friend? I know sometimes it be like say nobody send you. That's when I did for you, my friend.
Well, that was My Friend by Johnny Drill, and this is the Science Show with Dr. Dada on Jambo Radio Scotland, broadcasting from the city of Glasgow. Now we've come to the part of our show where we really home in on the question for the week. This week it is, how are metasurfaces transforming our world? And to join the conversation, you can call 0141 530 2787. That's 0141 530 2787. And we, as you probably know, we have two experts in the studio, and they will be breaking down this topic for us. So, to start with, what are these metasurfaces? And of course, this is to do with antennas and communication. So, Dr. Rahman, would you be able to break that down for us? Simplify how antenna design is pivotal to enhancing our daily digital interactions.
Well, as we work with any other electronic device, antenna is basically designed first on paper. We, try to model it theoretically, right? So we draw some figures. We have some equations, and based on these equations, we decide what would be the length and what would be the width of the antenna, and at which frequency it would be transmitting. So we have got a large frequency band where different applications work. As an example, we have got this mobile phone, and if we want to make a call, we are using GSM frequencies, 800 megahertz or 1800 megahertz. So according to the frequency of the application, we try to model the antenna, and then we have got some very specialist electromagnetic solvers, softwares. So in which we can design the structure in 3D, and then we can use certain parameters to see the performance, whether it is working well at the desired frequency, whether it is transmitting the desired signal in desired angles or ranges. So this all can be observed in these softwares.
Yeah.
Once we have got a satisfactory kind of structure with us, we can fabricate it. So we can use all these milling machines, and we can use the PCBs using different kind of metals, like copper is one of the most widely used metal to fabricate antennas. So we fabricate, and then we test in a lab environment, and we have got a very specific kind of environment called anechoic chamber. So this is a chamber that basically replicate free space. So we don't have any reflections and scatterings and
perhaps we could have the image from the University of Glasgow news report. I think there was something like that. Those foam, almost looks like the treated studios that you use for sound design and production as well. Yeah. So for those watching on the video, you can see what Dr. Urban is talking about here.
So we have got these cones, if I may explain. So these cones are very specific kind of material. We call them absorbers.
Yes.
So they can absorb the reflections and scattering. So they basically create a free space environment.
Nice.
So in this environment, we test the antennas, and we see that whether performance is satisfactory or not. So this is a very brief kind of process of antenna design.
Fantastic. Thank you very much for that. Yes, thank you. And perhaps Dr. Jabbar, would you like to then take us into what metasurfaces are? What on earth are these metasurfaces, and how do they differ from traditional materials as used in engineering and technology, and what have they got to do with antennas and communication?
Yeah, so that's a very right and interesting question, I would say. So meta is a Greek word which means beyond. So meta materials are such kind of materials which do not exist naturally in nature, and which have to have designed through specialized engineering. And once you design a material with a specific requirements, and that type of surface is said to have been called as a meta surface actually. So meta surface actually they manifest a lot of wave manipulation phenomena, and you can control the signals as per your requirement, which you cannot do through normal existing materials. So in antennas, actually meta surfaces are actually consisting of small elements which are specially designed to operate in a specific way, and each element behaves as sort of a pixel. You can control the radiation mechanism, you can control the output of that material in order to have the specific desired operation from that type of surface.
Fantastic.
So that is why we call it as a meta surface, and those properties are not available in conventional materials.
Fantastic. So you can engineer almost a new material.
Absolutely. Yeah.
Well, my background is optics, and I'm more used to metasurfaces for optics. So recently we published a paper where we used a metasurface to do polarization measurements, and the kind of thing that it's unheard of to have a single optical element doing that kind of thing. But with a metasurface, you can do engineering. You can kind of engineer the properties, the bulk properties of the material, so that it gives you some magical responses and things like that, which is fantastic. Good. Thank you very much for that.
So you try to realize the fiction, right?
Yes, exactly. You realize, for example, cloaking technologies also are very, you could design a material that basically makes you into an invisible man.
Yeah.
And
so it's just reflecting everything or scattering in different directions, and you are invisible.
Exactly. So metasurfaces are very interesting. Perhaps talking about the applications of these metasurfaces, could you share maybe how these are contributing to sectors like healthcare, environmental monitoring, or consumer electronics? You've mentioned a few of these already, but could you maybe just expand on that a little bit more?
Well, specifically metasurfaces is a class of, if I talk about the antennas, then it's a special category in antennas.
Yes.
So in antennas, we try to work out with conventional technologies, like we are just using a single element, standard metal like copper,
Yeah.
and then try to work out the geometry to achieve certain properties out of it. Or the other thing is we go for advanced and complex structures. So meta surfaces are these complex structures where we try to combine different elements or different layers or different materials or different shapes in order to achieve certain properties. We have got a number of application areas nowadays. One of the key area where meta surfaces can work is industrial automation. So it was one of the objectives of this work we are talking about.
Yes.
So in industrial automation, we have got a control unit that controls the whole industrial process. For example, if we have got a manufacturing plant, then we have got a control unit that controls the whole process. So if the communication between the control unit and the manufacturing plant is broken, if jammed, then we can go into very large economic losses and large shutdown times that can affect the whole system and whole supply chain. So these meta surfaces, when we can control the properties, they can very effectively establish that broken communication channel in a very agile kind of fashion. So in this study we have tested that we can re-establish the link in 5 nanoseconds.
Wow.
Yeah. So we can have alternative communication channels that can re-establish the system. So this is one of the areas where meta surfaces can be used. There are a number of other areas where if we don't have a direct link between the transmitter and receiver, then we can use the non-line of sight or indirect link to establish the communication.
Fantastic.
So we can use it in UAVs, we can use it in disaster management, we can use it in vehicular communication, we can use it in a variety of applications.
That's transformative indeed, isn't it? Yes, thank you very much for saying that, for sharing that with us. The other thing is, just for the benefit of some of us out there, the unit, the meta atom, as they say, that makes up the meta surface or the material that you engineer, what's it made up of? Is it just components, and what are those components?
So actually, they're not individual components. We have a naturally occurring, first of all, we have a material which we call as a substrate, and then based on our specially designed geometry, so small geometries are created on that surface with predefined, of course, calculations. And once the whole surface actually, whenever a wave or a signal impinges on that substrate, the behavior of that artificially engineered surface behaves in a way that we get to achieve the properties of a meta surface actually. So this is not occurring as an individual or a standalone element. We do use naturally occurring materials, but we engineer them in a way that they behave in the form of a meta surface applications.
Good. So in this case, you don't have things like resistors or things like that yet. It's much less built up than that.
It's sort of a substrate with specific permittivity and performance metrics. And then there's a sheet of conductor on that. And then of course on that conductor we create
these patterns.
Patterns, absolutely.
Good. Okay.
So we have got a number of smaller elements we place them together to create a surface
Good.
of those elements.
Good.
And then, control the properties of individual elements like phase in order to steer the beam, or in order to steer the radiation, for example, in a certain direction. On a certain channel, on a certain specific frequency.
Good.
To basically achieve
do what you wanted to do. Good. I was going to ask that. So properties like speed, the efficiency, maybe loss, properties as well, are the kind of things that you want to optimize to enable the next generation of capabilities. Fantastic. Good. So, there's a lot to say about metasurfaces, isn't there? There's so much we could say. But as we see, time flies by when we're having fun. But perhaps this is an opportunity, Dr. Masood, to discuss maybe say a bit more about your newest dynamic metasurface antenna solution for 6G systems. Is there any more that you'd like to share about it? Or perhaps Dr. Jabbar?
Well, this work was mostly led by Dr. Jabbar.
Yes.
I was just guiding him through the process. Just one thing, this is one of the pioneering step in this direction. So our proposed solution, the antenna that we have published recently, is first of its kind. It's very difficult to achieve such kind of structure at 60 gigahertz. So 60 gigahertz millimeter wave frequency is one of the key enablers of 5G and 6G. There are very few solutions available that basically provide the capability which is required by the millimeter wave systems. Our antenna is not just an antenna, it's a whole system. We have got the whole coding system, the controlling unit behind it.
I see.
That can steer the information in certain directions very fastly. So Jabbar can say more about this solution.
So I would like to augment as Dr. Masood said.
Thank you.
So metasurface antennas, one of the important aspects of these type of antennas for next generation communication and imaging is the carbon footprint and the utilization of power. The conventional phased array antenna systems which we see in our, for example, in satellite communication and airborne communication and even on terrestrial networks, they are power hungry sort of antenna systems. But metasurfaces based antennas is one of the new technology which can do wonders and which can give you the same level of performance, but with even more than half of that utilization of the power. So when we are reducing the consumption of power, of course we are reducing the carbon footprint which has to be generated from the source. So this is one of the sort of the green technology towards future, towards which the 6G is heading to actually. And of course this is one of the, as we go to higher frequencies, the design of antennas and the radio system becomes very, very challenging. So this was one of the challenging part of our project to design at such a high frequency. But indeed, it was the performance we achieved. It was absolutely remarkable and marvelous.
Thank you very much. That's fantastic. Great. Well, that's all time will allow us to say. But of course, yes, maybe on future episodes of the show, we will maybe delve a bit deeper into this topic of metasurfaces and all the weird and wonderful properties that they have. But before we go, we promised some science jokes and maybe a rap, a few bars of a rap from our guests, but we'll see how that goes. But first, let's share some jokes. Do you have any jokes you'd like to share, or should I start?
I think you should go.
Good. Okay. Now, here's one of the jokes. So this is a new made-up one, all right? Why don't metasurfaces ever get lost? Now these jokes, they're not really serious jokes. So if you think too hard about the answer, you're probably going to get it wrong. So the answer is because they always know how to find the right angle. I'm sure you can relate to that, right?
Yeah,
Talk about the angles. It reminds me of Balanis antenna theory.
Yeah,
exactly.
I did a course on antenna theory, so yeah, I can relate to that as well. Okay, what about this one? Why did the metasurface go to therapy?
Go to therapy
Yes.
because it has a healing effect.
Well, yes, it's related. Yes, I suppose that could pass as an answer as well. Here I have, it needed help dealing with its complex reflection issues. But yeah, there's no one correct answer to that one. So I'll give you that one. What about this? How do metasurfaces keep up with current events?
It can change its shape.
Yes, because they're always tuned
Optimized,
to the latest waves. Good. So, Dr. Jabbar, would you like have something to say? Would you like to say something about your funders, perhaps?
I would just like to especially thank my supervisor committee, Dr. Masood Rahman, and especially Dr. Kamar Abbasi, who is director of our communication research group.
Yes.
And as well as I'm also thankful to the University of Glasgow for providing a diverse sort of research culture, and where there is diversity breeds, but there is no division. So I really like this aspect of University of Glasgow and the UK education, and I hope I will cope with that. I will take it further to enhance my personal grooming as well as to share my knowledge, what I have learned over the globe.
So we always support brilliant students like Abdul Jabbar. As you know, the famous quote from Harry Potter's, right? In Hogwarts, help is always provided to those who ask.
Yeah, I see. Yeah, that's a nice principle, isn't it? And yes, indeed, I'd say your work is really outstanding. I know what it's like. You must be a very proud supervisor.
Really,
and I wish you all the best with your career moving forward as well. Great, and that's a wrap on this week's exploration to the fascinating world of science. And of course, you know where to come when you're looking for the latest developments in science, both from here in Glasgow and beyond. It's the Science Show with Dr. Dada here on Jambo Radio Scotland. And of course, we always love to hear from you. So if you have any thoughts, questions, or just want to catch up on updates about our show, you can reach out to us through our social media channels. You can also reach out to us via email, info@jamboradio.co.uk, and of course our homepage on www.jamboradioscotland.co.uk, and you can find our page for the show. It's /The Science Show, and there you can find all the latest news and updates for the show. We'd like to say a big thank you to you for tuning in, and we'd like to say a big thank you to our guests.
Thank you so much.
And with that, we'd like to say thank you so much for tuning in, and this is Dr. Dada signing off. Until next time, stay curious.